Oke, betul betul. Sudah terjang ya. Apalagi kalau ada pihak lain kan nggak bisa. Beberapa kayaknya nggak bisa juga, Prof. Irfan. Terus Pak Rudi ke Jepang apa gitu? Pak Alif ke ke Thailand, ya sudah, gimana lagi, nggak ada apa lah. Yang penting ya siapa yang bisa. Itu yang dengan Tokyo ya. Yang dengan Tokyo berarti aja. Roda ya. Itu kan juga nanti yang anak-anak nanti absen dulu kok Mbak yang sana. Oh, bisa di sini ya? Oke. Ini QR. Oh, bisa ya. Sama yang IUC saya double manual. Manual ya. Oke. Tapi kalau pada mau fingerprint juga boleh. Kayaknya pada kalian pada dulu situ kayaknya mau nunggu itu dulu. Ekonomi itu Kak yang dari Jepang. Rajin ya kalau. Oh, tadi itu juga bisa absen ini. Ini nanti yang Pak Iwan kan juga kita usulkan fisik. Oh, kejang. Oh, kejang browser gitu. Jadi ini Pak Marco, Pak itu yang Prancis itu Pak Pascal. Pascal ya. Pascal belum juga, ternyata belum juga diproses. Iya, dari prodi Itu beda sempat kita tapi ya
udah ini tak kayak contoh lengkap
yang dari anu lain
sama formnya segala macam wis mengari isi anu nyontoh nomor
nggak usah halo ya
ke ini bisa nggak orang mau gini bang mau kiri suruh bapak lima yo
apa
nah kalau yang dengan finger
oh blender anu sementara jangan bisa belum sampai ke yang profesor jangan bisa sama mau jual degree S3 juga tapi mungkin yang minat sumber daya tapi karena sementara yang ada sosek sama perikanan ini satunya sumber daya itu penggunaan sumber daya masuknya mungkin S3 ya tapi kita masih belum sampai ke draft itunya
ini ya kemarin satu kan formnya untuk udah diisi dan dia kan cuma copy and paste kan yang dia masukkan di situ kemarin data kirim ke dulu belum ke
diisi terus nanti ke senat
diisi terus upload di mengusulkan
fakultas ke
fakultas ya upload di mengusulkan ke fakultas terus fakultas katanya
SDM
padahal janjinya eksekutif apa gitu jadinya enggak begitu kalau dulu orang tak share namanya kan kita sudah punya bersama untuk 8 tahun loh.
Jelas itu sangat aneh ya. Kegiatan-kegiatan kan bisa diselipkan di project itu ya. Yang penting relevan. Itu Pak Marco. Halo, morning. Morning. Ini dari sana ke sini, Mas? Sana aja yang presentasi. Ini bisa? Enggak, maksudnya pakai komputer itu atau ini? Pakai ini bisa, nanti. Ya. Ini aja. Ya. Apa itu saya? Sama saya.
Ada air.
Alicia already included also the file. Your presentation file. Okay, yeah. Are you doing
I think you can try. But I'll be also included one place. Yeah, the 7 and 1 place. That we targeted only PBS. I wouldn't into the invader. So now we use it PBS is something or is the place. Some people on those plates then yeah. Mas Jalu belum udah happy ke ya lagi terus ada contemplating when that I said yeah we had the phase that as for PBS so we will see all the names because they all the phase so yeah
really oh yeah. Yeah, some related to the community, especially corporations. Oh yeah, ICT also, yeah. Just currently
I think fair enough idea. Usually it's like 3 to 4 days, then go as fast as 28. Because faster, once the money is transfer, it went up and down and up and down, so it can like going faster. So they have to go up 28. I'm going to be better at the yeah. So there. Overcome the problems. And I would check if you have something yeah, after lunch. Yeah. I just come up here when I
yeah. But he is also okay.
Yeah.
We are 3 here, Marco, you and me. Yes, okay. And then feel free. Yeah. Some international students also join.
It's fine.
Yeah, from Japan, from Korea and Vietnam, because we have international class. Yes. This one maybe from Japan.
Because we have signal and
So how do you change?
The operator.
Okay,
Operator.
yeah. The transaction. Yeah. Next.
If we also get a sign up during the presentation, you can. Yeah.
And we use this microphone.
Yes. Just to remind, check the class, and then some different, maybe from different buildings. Yeah.
Yes.
This floor, especially on the for meetings, no laboratory for this floor. For conference, training, or meeting, yeah. We have also small room. So yeah, last time we will be using the corner small room.
Yes.
you were talking last time in
This sample.
on the same room.
talk about the same audience.
Great.
Right side again.
In Indonesia actually also there is a document National Action Plan on Antimicrobial Control 2020-2024. I'm not sure in Indonesia or in English. Maybe in the in Indonesia, unfortunately.
But we will when we
Also supported by USID also. USID.
we will also analyze those when we do the field.
Yeah.
So that
There is document in English. There is document in English one.
oh yeah.
Indonesia and English.
Yes.
Yeah, there is the regulation from coordinating minister. Yeah, coordinating in economic. Not economic. Minister Human Development and Cultural Affairs. Just last year, 2021. But I will turn the attention to you.
Oh yeah. Very good. Thank you.
Maybe the class just finish and then check to the other class. The building in the corner. Maybe it takes time, but
There are still some scenes.
yeah.
And the first row
Yeah.
is empty.
Alright. Every time.
Yeah.
If there is no empty chair in the back, and then they just fill in the
Yes. That's always the same.
Not only the student, even the lecturer also. If there is a meeting, you should also always.
You know, you may get some assignments
Yeah.
also into administration.
Yeah.
better to try. Yeah, because you don't know what will come, so it's better to be a little bit background. I do that as well. Yeah, no, our students they prefer so on the side. So
Yeah. Okay.
This is the rest.
There are 5 from Finland. 5.
5, yeah.
5 in total.
Yeah, total 5. Yes. They have been here already for
a
month.
Yes.
Working
I will
the lab.
introduce to this week.
Yes.
So is Marco going first, or am I going first?
Independent. Marco or you? Because
You've been thinking.
Yeah,
I think
I'll be giving the
overview.
Yes. Yes.
Yeah.
And I have a few things that kind of lead the idea that sociology is needed.
Okay.
Yeah.
I even
But I also think biology.
Yeah, but it's good. But
Yeah, good entrance. Good entrance. Yeah.
But,
Yeah.
sociology. So this is last time. So
Okay. Good.
also the fourth.
You talked about it.
Yes, couple of times. Okay, this
So
one and this one.
Okay, good. We have.
But I not use Vimar because it's what is Vimar.
Okay. Well.
But I don't like that.
Yeah. Okay. But I'm glad we talk about it, but not anything. Exactly.
And it's obvious. It's kind of obvious that biology is
That's obvious.
it must be very hard for social scientists that which is not needed for AMR.
Yeah. Like what world uses them. But maybe you think that there are ways they're trying to do it.
I don't think it's the easy one. There are many seats, empty seats. Once, please.
You are cool.
It's from online.
Yeah, we set the hybrid.
And the code.
Oh yes.
Here's the
Attendance.
We can use this one.
Okay. Yeah.
good.
Yeah.
How nice we can see it.
Yeah.
And we used to have item for the attendance, but now by using the QR code.
Okay.
Yeah. Recording attendance.
So they also need it for that.
Yeah. Because if the absence offers 30%, they cannot join in the exam.
Okay.
So should be offer 70% attendance.
Yeah.
So they need
They need to show that they're
Mbak, silakan depan Mbak, ini masih banyak yang kosong daripada berdesak-desakan di belakang. Ayo depan nggak apa-apa. Sini Mbak, daripada kosong. Depan ya.
Yeah.
Silakan. Depan aja Mbak. Ada temannya Pak nanti. And then
How much time do you think? What time do you think you'll give for Q&A?
usually at most 10 minutes.
Okay.
Yeah,
great.
Yeah, 10 minutes. Okay. Okay, ladies and gentlemen, 6 minutes past, and then I think it is better to start this today's seminar. Good morning, ladies and gentlemen, Professor Marco, Alicia, Professor Siti Subandia, and also our colleagues from the University of Helsinki. This morning we will have kind of seminars on the issue of antimicrobial resistance (AMR). Even for me, this is new thing. So I suppose also I expect some students also still new thing. So this morning, I think Professor Marco will describe general overview and on EMR, and then later on Alicia will discuss about the social issues related to EMR. So this morning we have to distinguish speaker. For the speaker, Professor Marco is a professor from Department of Microbial, Faculty of Agriculture and Forestry, University of Helsinki. And then the second speaker, Alicia Kim, is a student in Department of Sociology, Faculty of Social Science, University of Helsinki. And the topic of the Professor Marco is antimicrobial resistance. Maybe some issues, general overview. Professor Marco, the student come from different class. Some really newcomers, maybe just first year, and then maybe some student postgraduate or some. This is quite diversified. So newcomers and some already advanced in the aspect of agricultural science. So maybe better to give a little overview and then more detail. And then times we expect maybe 20 minutes for each speaker. After that, we still have maybe 1 hour for discussion. So if we will offer to the all participants to give any question, either to Professor Marco or to Alicia. And then now time for Professor Marco, 20 or 25 minutes, please. And then feel free, you can sit on or maybe stand up. And then after that, continue to Alicia, also for 20 or 25 minutes. Please, Professor Marco.
Thank you very much for the introduction. I think I will stand up. 25 minutes. I was prepared for 45 minutes. So
Okay. 30 minutes is okay.
Thank you.
See how it goes. Do I see my slides?
Mas, dibukakan ya.
I have even.
Sorry? Okay.
You know,
yeah, it's okay. Yeah.
Because I got this opportunity, I want first to introduce Finland. And as soon as I see the slides, you can see where Finland is.
This one, Professor Marco?
No, that's mine.
No.
Oh no, yang satunya Mas. The file, the file. And join with us, Professor Marco, not only Indonesian student, but some international students from Spain, from Vietnam, also from maybe Korea, because we have international class, and we have 10 or 11 international students. Yeah. Belum bisa Mas Agil.
Always.
technical problems. Bukan yang satunya Mas. Ada 2 tadi di copy yang file pertama. Yang tadi ada abstraknya tadi, tapi yang depan.
Udah, kamu belum ya? Ada di grup.
Yes, this
Oke,
one.
oke. Enak, dibesarkan ya?
The mic is on.
Yes. Oke.
Thank you very much. Okay, now here you can see where we come from. Finland is in the northeast corner of Europe, and it's a bit far from Indonesia, but still it's
Very
our
fun.
country quite to reach.
Ngapain sih Nopi udah online? Apaan lagi ya?
Finland, if you think about Finland in the world, Finland is the happiest country in the world 6 years in a row now. And it's also a freest country of the world together with our neighbors. It's second least corrupted and third more gender equal, so Finland seems to be quite a good place to live. We have been a member of European Union since 1995, and it's relevant for many things, including legislation of AMR, so it's a EU-wide legislation. And then a few words about our university. University is quite old. We have a wide range of multidisciplinary degree programs. Most of our master's programs are international, so meaning that the teaching is in English. PhD programs, they are all international. And in Finland, you have quite great work-life balance. So in addition to work, we have also time to enjoy our lives. University of Helsinki can of course seen a part of our famous Finnish education system. And if you are interested in rankings, our university is in top 100 in most of the rankings. Here are a couple of examples of our international master's programs. You are already doing your master's, but you may have friends or relatives who are interested in studying abroad. So tell them to consider University of Helsinki. I'm myself mostly involved in this master's program in microbiology and microbial biotechnology. And we have, on average, 1 or 2 students from Indonesia each year. So we are getting some exposure in Indonesia. If you have any questions on studying at University of Helsinki, you can contact me for that as well. But now we can go to actual subject, antimicrobial resistance and One Health. Antibiotics are really miracle drugs. They are important not only for traditional infectious diseases, but medicine as we know it is very much based on the working antibiotics. Surgery, cancer treatment, and organ transplantation, for example, are not possible without working antibiotics. Childbirth, of course, is, but still much safer with antibiotics. Also, how we keep our animals is very much based on the use of antibiotics. Trouble is that the resistance always follows the use. Whenever a new antibiotic has been taken in the clinical use, resistance has followed sooner or later, and until some very revolutionary antibiotics develop, this is something that will happen also in the future. So that's why, in addition to developing new antibiotics, we should also be interested in how we can manage this development and spread of resistance. And why? It's very clear. It's such a selection pressure that Charles Darwin already explained. If we think about the microbial population consisting of different species with different level of antibiotic resistance, shown in different colors, if we put that population to selection with antibiotics, after the selection, only those ones that are resistant survive, and they will of course multiply. This situation is happening, for example, inside the body during the treatment. It can also happen in the environment because when we take antibiotic, most of the antibiotic compound is excreted from the body. And that's, of course, same with animals. When we give antibiotics to animals, they also excrete most of the compound. Also, antibiotic producing industry, they release wastewaters to the environment, and that can cause selection pressure in the environment. We must remember that things like metals and biocides can cause similar type of selection pressure, also for the antibiotics, which is a bit surprising. Antibiotic resistance in bacteria is in genes. Here is one bacterial cell that has a plasmid containing 3 different antibiotic resistance genes. They are shown in different colors. For example, the yellow one produces antibiotic efflux pump, so it means that it pumps antibiotic compound out of the cell, so it's not effective against these cells. And then there are 2 other ones. And if the cell has this plasmid, then it has resistance to 3 of these antibiotics. Then we know that gene transfer is a normal way of bacterial evolution. So bacteria exchange genes by different mechanisms. And that means that a cell that is sensitive to antibiotic can become resistant just by acquiring a resistance gene from another cell which has that gene. Let's skip out the transposons. We already over 10 years ago we studied this kind of a gene transfer in plasmids. So we took all the plasmid sequences from gene bank and studied how these plasmids share genes. The idea is that if they share genes, then there has been gene transfer event happening. And in this picture, we have plasmid for 2 bacterial groups. One is Acinetobacteria plasmids on the top, right? Acinetobacteria are usually antibiotic producers. Then the other plasmids shown in green, or different shades of green, they are plasmids from gamma proteobacteria. And many pathogens are gamma proteobacteria. These red lines show gene sharing event. So obviously there has been quite intensive and also extensive transfer of the genes between these plasmids. And we were also able to show that the transfer goes from Actinobacteria plasmid to gamma proteobacteria plasmids. So the pathogens can get the resistance genes from the bacteria that produce antibiotics. When a bacteria produces antibiotics, it of course has to be resistant to one that it produces, otherwise it would kill itself. So this gene transfer forms to a formation of a new resistant pathogen. It can also happen by mutation, so there is a mutation in some gene in the pathogen and then it can become resistant. This is, however, still quite relatively rare if we think about the environment, which means that it's also difficult to predict or model. We don't, in fact, really yet understand why this new resistant pathogen forms, what makes it stable, new pathogen. However, the selection pressure is important for this in a method that I just explained. Another issue is when we already have a resistant pathogen and it colonizes a new host. So it can be transferred from this pathogen from one human to another human, or between animal and human, or between animals. also between environment, for example, via wastewater or something like that. This is very common, and it doesn't really, there is really no difference between transmission of resistant pathogens or other bacteria. And this is quite well understood phenomena, so it can be predicted and modeled. Here the selection is not really critical. There is transmission anyway. What is important here is hygiene and sanitation. So it makes this transmission less likely to occur. There are many things that we don't understand in antibiotic resistance, but one thing is clear. More there is use, more there is resistance. In this figure, x-axis shows the total antibiotic use for humans, adjusted with population, and y-axis resistance of one pathogen. And there is clear correlation. But however, if we compare, for example, China and Australia, they have almost identical antibiotic use, but very different resistance level. So why is that? We don't know exactly, but one major reason may be antibiotic use for animals. Because in China, they use huge amount of antibiotics for animals. And it's unfortunately in the sense that it mostly goes for healthy animals, not really treatment, but it goes for growth promotion or prophylactic use of, these two. And this growth promotion and prophylactic use is forbidden in EU, Japan, Canada, at least in principle. Even US has now some restrictions, but it's a bit unclear picture. When we think about global scale, antibiotics for humans, they are over-the-counter drugs, so you don't need a prescription. If prescription is needed, then doctors, veterinarians, they are very keen to prescribe. They can also sell the drugs and get maybe even most of the income by selling the drugs. So that makes control of antibiotic use quite challenging. Then, what other things can contribute? Here are 3 different maps. On the top right is the antibiotic resistance situation in different countries, shown in traffic light colors. Then on the top below right side is the corruption and governance quality in those countries, and bottom left is the level of infrastructure in those countries. And especially this corruption and governance overlaps quite well with antibiotic resistance in those countries. So there are obviously many things affecting that we don't really understand. You have already heard about One Health, and antibiotic resistance is of course very much One Health problem. Human health, animal health, and environmental health are just different sides of one picture. And these kind of local One Health circles, so here they are connected with travel and trade, maybe also things like animal migration. Then a few words about how to study the environmental bacteria. Pure cultures, like Louis Pasteur started some 150 years ago. That's great, but if we think about the environment, only small fraction of the species grow with the current methodology. That can be improved, but however, when we isolate bacteria from its environment, it loses social context, and its it is really important for bacteria. They communicate with different species when they are in the environment. So if you want to study the real world situation, we must use molecular methods. But I must note that if you are interested in pathogens only, then culturing is also a very good method. There are two major types of molecular methods. One are PCR, polymerase chain reaction based. These can detect very small amount of target, which is very useful. They can be very specific, but of course the primer design is critical for that. They can be used for presence absence studies, which is very relevant if we study isolates, for example, and the target sequences can be sequenced after the amplification. Then there is quantitative PCR, qPCR, which gives us the amount of target gene. This can be done in high throughput. I mean, measuring hundreds of genes on one run. It has very high dynamic range. And if you are interested in using qPCR methods, you should start by checking guidelines, for example, from this paper. Then we can use metagenomics. You have already heard about the metagenomics, so I'm not using too much time for that. But it means isolation of all DNA in the sample and then direct sequencing of the DNA without any enrichment, culturing, or preferably also without any amplification. And here we can, of course, study all the genes in a sample. We can also analyze the genetic environment of the target gene, if the AMR gene is in mobile genetic element, for example. However, we cannot solve the hosts for the plasmids, at least not yet. This can be done with short reads or long reads, which you have already heard. And if you think about the AMR genes, there are many resistance gene databases available, and the database you use has a big effect on the results, so you should know which database you use. I have some time to show our result on antibiotic resistance in the environment. I will start with the wastewater treatment plants. Wastewater treatment plants, they are meeting place for bacteria from humans, animals, and environment. They also receive pharmaceuticals, for example, antibiotics. Then we remember that most of the antibiotics we get, we excrete. So these meet in the wastewater treatment plant. That's why the wastewater treatment plants have been successful to be a hotspot for antibiotic resistance. In order to understand that, we studied 12 wastewater treatment plants in 7 different European countries, and we used qPCR and quantified almost 400 antibiotic resistance genes. And we normalized the resistance gene numbers with number of bacteria in the sample by using 16 as ribosomal RNA gene counts. And here is the principal component analysis picture of incoming wastewater. And we see here that the countries, they group to 2 different groups based on the antibiotic resistance. And when we analyze antibiotic use in these countries, we can also see that these are countries with low antibiotic use and high antibiotic use. However, this low and high antibiotic use also overlaps with the latitude. So low antibiotic use countries are from Northern Europe, and high antibiotic use countries from Southern Europe, from Mediterranean countries. And these countries, they are, especially with the summertime, they have very high temperature, even higher than in Indonesia. There can be over 40 degrees in Spain and so on. So it's comparable to Indonesia, for example. Then we were interested in if these wastewater treatment plants are really hotspots. And what being hotspot should mean that there is some selection of antibiotic resistance, amplification of antibiotic resistance, meaning relative increase of the resistance. However, our results show here that for both high and low antibiotic use countries, there is in fact relative reduction of resistance to the purification. So resistance per number of bacteria decreases purification. And when we compare this thing with the fact that there is some big reduction of number of bacteria during the treatment, something like 1,000-fold reduction in number of bacteria, we can conclude that the wastewater treatment plant is not a real hotspot if it works well. I would argue that the treatment plant that we had in the study, these are some of the best in the world, because they are very happy to participate to our study, and they always wanted to know more about their process in order to improve it. So we don't know if the treatment plant doesn't work well, if it's hotspot then. Anyway, the results show that if the treatment plant is good one, then it's possible to be not a hotspot. This one. And go to low and middle income countries and AMR. Low and middle income countries, they have higher burden of infectious diseases with the smallest resources. There's usually limited data on AMR in low and middle income countries, and also lack of systematic surveillance. I have two examples of low and middle income countries of AMR, and one is Indonesia. This is a study that we did some years ago together with UGM and University of Helsinki. This was very much initiated by Ilmi Musiasari, postdoc in Malat at that time. Now, like many of us know, running our own company. So we used array PCR, again, analyzing almost 400 resistance genes. And here is our team in Finland, during winter. Sadly, two of our Indonesian collaborators have passed away.
Pak Iwan.
We studied the Sode River that you know very well for AMR, and we sample starting from the Merapi, where the river starts, and then sample in different places along the river. Before the Yogyakarta and after Yogyakarta. And we can just have a look at the panel A here. First, we didn't find any antibiotic resistance in the spring where the river starts. Then when we went to this first rural site, we found AMR genes. Then we went along to the city, where the abundance of resistance was higher. It was also statistically significant. Then in the estuary, very close to the Indian Ocean, the abundance of resistance gene was highest. However, it was not statistically significant, mainly because there was so much variation between different samples in the estuary. I think it's because there is some mixing of river water and the sea water. So the situation is not stable in the estuary. We can also have a look on each individual gene that we quantified in this heat map. And here it's easy to see that there was nothing in the first sampling site, the spring where the river starts. We didn't see anything, but then when we went along, there are highest number after the city of Yogyakarta, And then last two samples on the right, some of the genes, they are present in very high numbers, but most of the genes are shown in white, meaning that we didn't detect them at all. Then another example, which is a hospital wastewaters. Hospitals, lots of antibiotics are used in hospitals, and over half of the patients receive antibiotics when they stay at hospital. And the treatment of hospital wastewater is very different in different countries. Some hospitals, like here in Georgia, may have a dedicated purification of wastewater. In Europe, usually there is no separate purification, but wastewater is just released to the municipal sewage. In many countries, in Africa, for example, infrastructure may be almost non-existing, something like leaking septic tank. We analyze hospital wastewaters in Benin and Burkina Faso in West Africa. And here we can see, for example, the temperature of Benin and Burkina Faso. It's quite similar to Indonesia, in fact. In Finland, we sampled during the winter. We had very mild winter, so temperature was between -5 and +5. We sampled many Finnish hospitals, and the idea was to compare these African hospitals with Finnish hospitals. This was work by Melina. Melina probably already presented this work, so I will just very briefly show the results. On the left panel, we see the total relative abundance of the antibiotic resistance genes, and it was highest in Benin, followed by Burkina Faso, and then in Finland. This is not really reflective, for example, with antibiotic use in these different countries, although that it's difficult to get reliable information on antibiotic use in Benin and Burkina Faso. But since Melina probably showed this already, I can go still use a couple of minutes for talking about agriculture and AMR. As I said, most of the antibiotics globally are in fact used for agriculture. And there are selection pressure because of that in the guts of different farm animals, and they also excrete the antibiotic compound and antibiotic resistant bacteria in the feces, so they end up in the environment. If the manure is used as a fertilizer, then they may end up with the plants. If the runoff waters are used for irrigation, they may spread AMR. So this is very complicated picture. And it also, there's difference between humans and animals that almost never the agricultural wastewater, for example, are purified. And if the manure is used as fertilizer, then the AMR will end up to the environment. And it has been shown that if the animals are receiving antibiotics, then there is an increase in antibiotic resistance in their manure. And if the manure is used as fertilizer, there is also increase in the antibiotic resistance in soil. What is maybe even more surprising is that manure increases antibiotic resistance in the soil even without antibiotic use for animals. And this is probably due to the metals present in manure, because many feeds contain high amount of metals, especially copper and zinc. We studied this effect together with Christian Brandt from Denmark. We did an experiment when we treated soil with copper, or zinc or tetracycline separately, and then we monitored resistance for tetracycline. And here we can see that both copper and zinc, they increased tetracycline resistance in soil. So there is clear co-selection of antibiotic resistance by these metals. Which is perhaps quite surprising, was that the treatment of soil with tetracycline didn't select tetracycline resistance. And the reason for that was that the bioavailability of tetracycline in at least this soil was extremely low. And I think in order to keep in time, I will skip these. I will also skip this. And continue from here. So there are many different human activities and kind of places in the society that play a role in antibiotic resistance. However, we do not know the relative importance of different activities. So we don't know how big these arrows should be. And this is really something that we should understand. Our current work now is on the understanding the emergent spread of AMR and the contribution of different human activities on that. And we do the work in a multidisciplinary environment, having research groups working in biology, medicine, data science, and sociology. And we have a global approach on that. Here on the red dots are our study sites in the globe. We work in Benin, West Africa, in Indonesia, here in Jakarta. And we also work in Bangladesh and Southern Europe. Here in Indonesia, we collaborate of course with Professor Siti and also Professor Anis from UI. And we are on the process of finding collaborators in the social sciences, and Alicia will maybe say something about that. And this is my last slide, so I can conclude by saying that the more we use antibiotics, more we have resistance, but also other things contribute. And there is a lack of understanding the big picture of AMR, meaning microbial ecology and evolution in different environments, and especially the sociology of AMR. We of course know that there are a couple of things that are important. Vaccines, because they reduce use of antibiotics. The same goes with sanitation. And then education in many different levels. We should educate, more people to understand how diseases spread, when antibiotics are needed and when they do not help. We should also educate medical doctors and veterinarians, the same thing, when we should use antibiotics and when not, and how to improve diagnostics of infectious diseases. And I will stop here. Thank you for listening. Terima kasih.
Terima kasih.
So, will there be questions now or afterwards?
Maybe about having a direct discussion or waiting Alicia? Discussion? Okay, yeah. Because a little complicated, maybe will be forget after too many information. Yeah. So we offer maybe some question from the participant, please. Please tell your name and maybe affiliations, which year and then which department or study program. Please. Okay. Please. Okay. Using this one. It's okay. Yeah. Please tell your names and affiliation.
Okay, thank you. My name is Abidaki, and I'm from Technology UGM. And I want to ask you about, is there any relation between split up IMR and the weather or season? I mean, is there any relation split up IMR in the dry season or in the wet season or summer or anything? Thank you.
Thank you very much for the question. And I have to say that really I don't know. And yeah, there is no that kind of, we don't have that kind of seasons in Finland like you have here. So maybe I will let that for you to study if there is a difference.
Dry season and wet season in Indonesia, we have to. Yeah, chance for the study in the future. Yeah, you could join in this program. Oh, but in Finland, because in Finland there are 4 seasons basically.
Yes.
There's any difference?
There is a big difference, and I think having winter, I mean, soil gets frozen, topsoil gets frozen, so that helps a lot with the AMR in agriculture. We only have one harvest per year, which is, you have 3. You will get much more product, but you will also probably have more problem with the pathogens and AMR. Having 3 or 4 months of winter kills or inactivates most of the pathogen in soil. So although it gives less yield, it also beneficial for some things.
Okay, thank you, Prof. Marco. Prof. Tia?
In the winter, maybe some of the AMR lost, but what about due to the low temperature, even if this preserve AMR? What do you think?
Yes, that's a very good question. And temperature in general, of course, helps you with the pathogens. If the temperature, like now here, is almost 37, it's good temperature for pathogens to grow. In Finland, with some days during the summer we may reach 30. Usually it's between 20 and 25. So that means that the pathogens, they do not really have competitive advantage. So the cool climate really helps with all the pathogens. Also, of course, the waters, rivers, here they are much warmer, which means that again pathogens are thriving in Finland. For example, wastewater, the temperature is maybe around 12 degrees. So it's not a very good temperature for pathogens to grow. So yeah, just because of climate, you are having much more problems.
Tropical.
It's not fair. But of course, you can also grow many things that we in Finland cannot grow, and you can get much better yields. So it's kind of like always, it's a trade-off.
Okay, thank you, Prof. Yeah. Still, there are some questions maybe. Any other question, please? Any question is okay. Accept it. Comment also okay, not on the question, but in bahasa also okay. Yeah, we try to translate. In bahasa, in English okay.
Bisa ditanya. Mumpung ada kuliah gratis
ya.
Loh.
Ya.
Biasanya datang ke sini sendiri.
Yeah, please. Even general comments okay. Yeah, not technical comment also okay. Please.
You can also ask if you didn't understand something.
Kalau nggak paham,
Yeah. 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 Okay, please. Yeah. Please, you. Okay.
Once more. You said you are expert in wastewater treatment, and you only say that I am plant water treatment can reduce the AMR. How about the chemical water treatment? I mean, in the wastewater process, some we should add the chemical to decrease the microbes. Is it has relation with split of IMR? Thank you.
That's a good question, and it's if we think about the wastewater treatment plant, there is almost always there is this activated sludge, which is not perfect in removing bacteria. So what to do after that? It has been very much discussed in Europe, and there are different ideas kind of we could add at the end of the treatment before the wastewater is purified wastewater is released. And there are a couple of options that have been used. One is UV treatment, one is ozone treatment, even activated carbon has been planned. Not so much chlorination, because chlorine is not very effective if there are organic compounds present, which there still are even in purified wastewater. Also, chlorine is, I think there is, if you use it in a big scale, it's kind of it's a bit dangerous to have chlorine gas or something like that, or anyway it ends up to the environment. So chlorine is not very much discussed in Europe. Then if we think about the microbial ecology, using any of these disinfectants, UV, ozone, chlorine, they've all increased mutations in bacteria. They also activate so-called source response, which means that the bacteria, the horizontal gene transfer between different bacteria is activated. So in theory, it has been presented that using these things may in fact increase AMR because of these mechanisms. But I would argue that this is a theory which has not really been shown. But it also depends on where the purified wastewater is discharged. If it's discharged to, for example, river, then it should be, hygienically very good level. So no pathogens, no bacteria, because there are humans living in downstream. If it's released to sea, and maybe a couple of kilometers offshore, then there is no immediate health risk. So then the hygiene is not that critical.
Okay. We have also some participants joining on Zoom. Please, if there is any question from the participant from Zoom, either writing a message or directly giving the question, please. We have 36 participants from the Zoom. Yeah. Any other question from the Zoom? Okay, we still have time. Please, if there is any other question from the back side. Back side. From international student, any other question? We have a student from Japan, from Korea, from Vietnam. Maybe the different situation. In Japan, maybe different situation with Indonesia, Europe. Still? Any question, please? No question? Okay. Yeah, if no question after Alicia, if still you need some additional information, maybe of course Professor Marco still will answer your inquiry. Okay, thank you, Professor Marco. Shall we give applause to Professor Marco? Yeah. But if still there is a question later on, Professor Marco still can answer the question. And the time for Alicia. Yeah, please, 30 minutes or more. No time for discussing about the social aspect on EMR. Yeah. Closely related with technical and social aspect. Please.
All right. Hi, everyone. I'm Alicia Ing, and I'll be giving a talk today on the social study of AMR, making AMR intra and interdisciplinarily. So welcome to welcome to today's talk. I'll be talking for about 30-40 minutes. So yeah, thanks for your attention. Yes. So the outline of today's presentation, there will be many overlaps with Prof. Marco's talk. I'll first be giving a short introduction on what are antimicrobials, what is antimicrobial resistance. I'll then talk about the biological as well as the social drivers of antimicrobial resistance, AMR, and their connection a bit. I'll then dive into what is the social study of AMR, including what are the social drivers of AMR. And we'll be looking at these from like different scales. We'll be going from the global to the local scale. And we'll be talking about intra, so within the disciplines of the social sciences, intradisciplinary connections in the social study of AMR. And then we'll move on to the interdisciplinary study of AMR. So, for example, between social sciences and biological sciences. And I'll talk about this project, in my presentations called FEMAR, which is Marco mentioned as this study we're doing, going to be conducting here in Georgia. And then conclusions. So, to begin with, antimicrobials, what are those? Antimicrobial drugs are medicines that are active against a range of microbial infections, such as those caused by bacteria. So those drugs are known as antibiotics, and antibiotics are probably a word you're very familiar with, but there's other antimicrobials also around. For example, against viruses, they're called antivirals. Against fungi, antifungals, and against parasites, these include, there are many names, but these include antimalarials. And antimicrobial drugs, they're a major medical instrument in the fight against many infections and diseases found in humans and animals. Generally speaking, worldwide, antimicrobial use is found or based out of hospitals and pharmacies, animal agriculture and veterinaries, and in plant agriculture. However, while antimicrobial use kills microbes such as bacteria and inhibits their growth in the short term, and it is something we largely depend on to stop bacterial and fungal infections, antimicrobial use has ironically led to the proliferation or growth of resistance to antibiotics. This is known as antimicrobial resistance, or AMR. In short, antimicrobial, especially antibiotic use, is a key driver of antimicrobial resistance. And since the widespread emergence of antimicrobials in the 1940s, AMR has developed into a major worldwide human health and animal livestock health problem. So AMR arises, well, Marco has discussed this bacterial cell looks familiar. AMR arises when the microorganisms which cause infection, such as bacteria, survive exposure to a medicine that would normally kill them or stop their growth. So in the top image, we see well, maybe it's hard to see it for you, but let's go through it. So at the top, there's 4 different panels. And in the first one, it says there's lots of germs, so let's say lots of bacteria, and a few of them are drug resistant. In the next panel, antibiotics are given to kill those bacteria. And antibiotics work in a way where they kill all the bacteria or most. So this, they will call, if you're having some kind of illness or disease, the antibiotics will kill the good bacteria as well as the bad bacteria. However, there will probably be some drug-resistant bacteria in a given system. So in the third panel, the drug-resistant bacteria are now allowed to grow and take over. So you can see this pink bacteria starting to take over. And in the fourth panel, the last one, some of these bacteria now give their drug resistance to other bacteria, causing more problems. So that, in brief, and in a rather basic but clear way, that's how antibiotic resistance happens. And on a molecular level, so looking a bit, maybe some of you are more familiar with the lower image. On a molecular level, we know antimicrobial resistance is driven primarily by horizontal gene transfer, which Marco talked about, and horizontal gene transfer of antimicrobial resistant genes, or ARGs, between bacteria. This biological mechanism is very important, as microbes such as bacteria can transfer genetic information on how to resist and evade antimicrobials to other bacterial communities. And we can understand these biological mechanisms, such as horizontal gene transfer, as the biological drivers of AMR. And the image below, as Marco has already showed, it shows different mechanisms that bacterial cell can have to become resistant or to resist antibiotics. So the main drivers of AMR emergence and spread are from the ability of bacteria to quickly spread antimicrobial resistance genes laterally through horizontal gene transfer, which we just discussed, and that's the biological driver. Resistance genes occur naturally, that is, microbes like bacteria carry resistance genes, but their spread is exacerbated by the next point, which is heavy selection pressure on the bacteria to exchange resistance genes due to high human-made or anthropogenic inputs of antibiotics and other substances in the environment. Prof. Marco mentioned heavy metals. So in other words, people drive the spread of AMR, and this is what I term a social driver in this presentation. So, okay, people put many antibiotics into the environment, which drives the biological emergence of AMR. What drives people to do this? There are many social drivers, and many are interconnected. So if we look at the image on the right, I'll get into this in more detail shortly, but this gives an idea of the various complex social drivers that might be present and the complex ways that AMR can spread throughout society and throughout the environment, animal and natural environment. And we'll also return back to biological drivers and the relevance for social aspects of AMR later in the presentation as well. So AMR is a global issue. So these concerns about AMR's emergence, rise, and impact have become a major worry for human health globally. So this long quote on the left, this has to do with the dependence on antibiotics in medical practice. And the O'Neill review on AMR from 2016 has stated that if antibiotics lose their effectiveness, key medical procedures such as gut surgery, cesarean sections, joint replacements, and treatments that depress the immune system, such as chemotherapy for cancer, could become too dangerous to perform. And sadly, as with the impacts of climate change, most of the direct and much of the indirect impact of AMR will fall on low and middle income countries. So note the impact on low and middle income countries here So while much of previous research on AMR was done on the global north, AMR is a global issue, and much current research is exposing the overwhelming impact on the global south, which includes Indonesia. And the quote on the right, I'll read it out. Drug-resistant diseases already cause at least 700,000 deaths globally a year, including 230,000 deaths from multi-drug resistant tuberculosis, a figure that could increase to 10 million deaths globally per year by 2050 under the most alarming scenario if no action is taken. Okay, so let's return back to the image from a couple slides ago. And thinking on more of a systems level, it is known that the crisis with AMR prevalence is driven by human-made or anthropogenic causes. Much of this has been identified as the overuse and abuse of antibiotics. As Marco mentioned, more use equals more resistance. So this includes industrial agriculture and human public health. And while the transfer and spread is among bacterium, AMR ultimately affects human health and the health of animals in close proximity to humans, such as livestock animals bred for consumption. So this is a social issue. The spread of AMR is caused by people, including individuals and communities, as well as societal structures, including policies and practices. And this is in no way to discount biological drivers or the biology of AMR, but to make a point that much of what makes AMR so dangerous, prevalent, and complicated is due to social factors. We can see many social drivers at play in this image. We can start at the hospital, which is at the top middle. And this is where many antibiotics, for example, are given to treat serious disease and infection. So in the hospital, there are various policies and practices that might be in place here regarding who gets what antibiotics and how many antibiotics they're giving. Policies could be at the national level, or they might be governed by the hospital itself. And going from the hospital, antibiotics are also given in varying degrees depending on country to animals bred for consumption. So maybe on the right hand, where there's this cow and pig and chicken. Again, these are subject to policy, like on animal husbandry, but these are also subject to practice. For example, a farmer's own daily practice in dealing with diseases that affect their animals. Antibiotics can also be acquired over the counter from pharmacies in some countries, like here in Indonesia. I'm not sure where the pharmacy is in this picture, but maybe they're on the far left or above the cow. So resistance can be initiated in multiple places, but it can spread by humans and animals across multiple locations. So the idea is that one can acquire antimicrobial resistance in either of these locations, but the spread is happening from the excretion by humans and animals and things like that. And one significant point of spread is the built environment. So down kind of in the center left, you can see a wastewater treatment plant. Another built environment includes sewers. So the sewer and wastewater treatment plant is known as a point of spread of AMR and ARGs. But AMR can also enter the natural environment to waterways, again, cycling around food, animals, and back to humans again, cycling around. So yeah, there's a few things to note about this image. One is that this shows many social drivers and ways of AMR spreading, but there are other social structures that are not really depicted here, such as surveillance, which is quite a hot topic right now in the social study of AMR. So one form of surveillance, for example, is in hospitals. For example, screening patients when they enter the hospital for antibiotic resistance. But there's many other types of surveillance. And another note is that these are all sites where bacteria can exchange antimicrobial resistance genes, especially in places where difficult to survive environments drive selection pressure. And the last thing to note of this image is the potential that the individual use of antibiotics, if used wrongly, can affect the community level. So if many individuals put antibiotics into the environment, there is a possibility that this drives selection pressure on bacteria, which can spread through the environment, including back to human bodies through, for example, consumption of food and water. So this leads me into the discipline of sociology and the field of the social sciences more generally regarding the social study of AMR. What is it and in what ways can we think of the social as regards AMR? Sociology is the study of social life, social change, and the social causes and consequences of human behavior. In sociology at the moment, main areas include social movements, discourse, organizations, race and ethnicity, and demography. So it's quite a large spread. And there's many other subfields of sociology. So while sociology does engage with the topic of AMR, so do many other disciplines. That is why I wanted to refer to this presentation as the social study of AMR rather than the sociology of AMR. So if we go one level up from sociology, we find two branches of science related to humans and society. So the first one is the social sciences, which is a branch of science that deals with the institutions and functioning of human society and with the interpersonal relationships of individuals as members of society. And secondly, there's the humanities, which is a branch of science that deals with human culture and expression. Disciplines within the social sciences and humanities related to AMR include anthropology, sociology, geography, economics, psychology, communication, philosophy, history, and design. And some of these I'll go more into later in the presentation. So there are many ways to engage with the social aspects of AMR. And to give some more pointed examples, so some subfields within the disciplines include public health, public policy, there's medical anthropology as a subfield of anthropology, there's a subfield of sociology known as environmental sociology. One can also study the history of AMR, social discourse around AMR, and then one can also study built environments such as hospitals or sewers, things like that. The mechanisms which lead to antimicrobial resistance are biological, as we established. However, the conditions promoting or mitigating against these biological mechanisms are profoundly social. So as described by medical sociologist Professor Dame Sally McIntyre in 2014, how our farmers, vets, and regulatory systems manage livestock production for human consumption, how regulatory and fiscal frameworks incentivize or deter antimicrobial development, production, and use, how the public and healthcare professionals understand, value, and use antimicrobials, the context in which animals and humans interact, and the ways in which particular groups of humans are exposed to particular microbial infections. All of these are shaped by social, cultural, political, and economic forces. This points to the complex drivers of AMR, many of which are overlapping and contingent, which means one thing is determined by another. And this includes social aspects such as policies, structures, practices, economics, social awareness, etc. These can be analyzed at varying degrees of scale, such as global AMR policy and global AMR standards, to local practices to mitigate AMR through hygiene practices or social awareness of AMR in the general public, or say in a hospital. So I'll turn now to some of these examples at different scales. And I'll take a drink first also. Okay, so to go into these complex social drivers of AMR, let's start at the global policy level and work our way downwards to national and then local levels. So at the global policy level, we have, for example, the World Health Organization's Global Action Plan for Antimicrobial Resistance. This was initiated in 2015 and is a framework for standardized guidance on AMR. The Global Action Plan has identified 5 key objectives with the aim of ensuring the continued treatment and prevention of infectious diseases with the use of antibiotics. And the 5 objectives are to improve awareness of the resistant problem, strengthen research and surveillance, reduce incidence by improving sanitation, optimize the use of antibiotics in humans and animals, and develop the economic case for alternatives. We can see that there already are many overlapping issues that need to be addressed, such as awareness, research and surveillance, sanitation, optimized antibiotics use, and economics and economic alternatives. So that was quite brief on the global level, but we'll start to go lower down now. So countries signing up to the Global Action Plan are expected to make a national plan specific to their country. And this national plan we'll go into next for the global national level. And we can look to the 2022 study done by colleagues of mine at the University of Helsinki. The Sariola et al. Study was conducted on Benin and Burkina Faso, which are 2 countries in West Africa. We saw a map of where it is earlier. And the study covered their national AMR global action plans. The study found shortcomings in all of the global action plan objective areas. And interestingly, many were interdependent and contingent with each other. So for example, they documented, and you can see on the left, these bubbles regarding antibiotic use. They documented the lack of regulation of antibiotics, which means that antibiotics are easy to acquire. One doesn't need a prescription to get antibiotics, so antibiotics are widely available. The study also documented that there is low public awareness, so that means that not many people know the dangers that AMR poses to human health. And yet the study pointed out that it is more the lack of regulation and pressure on healthcare practitioners to deliver treatment that drive the widespread use of antibiotics. So this finding, shows that there is something socially driven there, but crucially it is an interpersonal social aspect that is easily missed from the GAP objectives. So there's something missing in a way between the global level and what they want with more of the national and local level of what's going on the ground. And just to inform you, the world map here on the right shows the frequency of non-prescription antimicrobials used in general populations around the world. This is from 2011, but I couldn't find a more recent study that is as comprehensive as this one, so things might have changed. But you can see Indonesia is here, and it's in green, so it's in the middle of the scale, which means that non-prescription use is between 5 and 19% of the general population. So it's not as high as countries like China, Italy, or Sudan, which are in purple and red. But still, it is, I suppose it's still quite significant. So again, from the global to national policy level, we have another example from the same paper. We find that research and surveillance, which is another global action plan objective of improved research and surveillance was found to be lacking. And the authors note that this is despite the fact that the researchers and health practitioners in Benin and Burkina Faso, they're very highly motivated, and they try to equip their laboratories and train their research staff to be able to fill the data gaps from their countries. However, while research is strong with respect to social interest and motivation, things like good surveillance hinges on many structural factors, such as the tools and infrastructure for testing and sample transport, as well as streamlined protocols. So surveillance requires quite high infrastructural levels, basically. And the surveillance of AMR should generate information on the incidence, prevalence, range across pathogens, the geographical patterns related to antimicrobial resistance to guide the treatment of patients. And surveillance should also inform local, national, and regional actors, and it should also monitor the effectiveness of interventions with regard to how resistance develops and spreads within and between humans and animals through food, water, and the environment. In these countries, because there is no infrastructure for sample transportation, so for example, a hospital will take a human sample, say a fecal sample, and it has to be transported to a lab, to get, say, metagenomics on it. In these countries, there is no infrastructure for that. That is, there is no way to quickly and safely ship samples, say, from rural areas to the capital city. And the shipping that does exist is expensive. So this is one factor in why no standardized system for surveillance exists. These reasons can also be co-contingent, which means that, for example, shipping samples is expensive because no standardized system for surveillance exists. So kind of the things go both ways. And Sariola and colleagues refer to these kinds of phenomenon as the stacking of lacks, which is pictured on the right. And it's where the additive and compounding effects on fractured health and veterinary systems, sanitation and laboratory infrastructures reveals the various lacks and their interdependencies, making it difficult to know where to begin to intervene. So as we can see in the image, oh, sorry, my bad. Oh, I'm sorry, everyone. Please shout out if I've forgotten to change the slide or if nothing makes sense. So this is the previous slide, which is on structural factors related to research and surveillance. Now we're here. So this is referred to as the stacking of lacks. You can see the image on the right. There's this hospital, which represents a fractured health system, and it's being propped up by bottles of medication, and that's supposed to be antibiotics. So the antibiotics are propping up the various lacks, in this case, patient care and hygiene in a fractured health system. The image also shows that productivity remains high and remains the key interest in what props up these broken systems, while concerns such as the equality of care provision or the equality of, say, development is ignored. Okay, so now to bring us down to the local level of the complex social drivers of AMR, we turn again to the Sariola paper from 2022. And focusing on the left side of the slide, one section focuses on local issues regarding water and hygiene in Benin and Burkina Faso. In both places, it's difficult to find clean water, and to drink with and to clean with. This is compounded by the fact that water infrastructures like sewers are not the norm, don't exist really. So water use is generally household to household, where people access water from a well or from a tank. People interviewed for the study, they did understand the significance of clean water for good health. However, they had trouble accessing water and spent considerable time and money daily accessing clean water. This means that maintaining hygiene and sanitation, like just washing your hands with soap, for example, is very, very difficult. So this has implications for human and animal health. And overall, this means that the spread of infectious diseases is high. So to quote the paper, the lack of sanitation and the potential flow of contaminated water means that resistant infections are spreading. And we now turn to the right side of the slide. As another example of local level drivers of AMR, you can use the example again from my colleagues from 2021. This paper was also on Benin and Burkina Faso and focused on animal infection control, which is also known as farm biosecurity at chicken farms. So here we see various drivers around the use of antibiotics for two types of chicken. So one chicken is more resistant to disease, but doesn't grow as quickly. And another chicken grows more quickly, but it's more prone to disease. And so which chicken a farmer decides to raise will affect their use of antibiotics, including when and how much to use if a chicken gets sick. So farmers have to make very tough decisions in their daily, day-to-day of what chicken to choose and how to care for it. Considerations over animal health and trying to avoid disease also affects the practices and choices of farmers, but also veterinarians and their sanitation practices. These considerations are interestingly also tied to economic factors. Growing many of the quicker growing chickens can be economically advantageous. So this can potentially give the farmer more money when the chickens are sold. However, it can also be a risky venture. The chickens might get sick, and then one must consider how many to treat with antibiotics, how many to kill, and while also trying not to lose too much money or not provide enough chickens to the market. Many of these farmers are small or medium scale, and they operate on very tight budgets. So their economically precarious finances encourage them to use antibiotics in ways that go against guidelines and safety rules, such as giving an entire flock antibiotics when only some are found to have disease, despite standards saying that they shouldn't do this, and this is against good farming practice and good practice to lower AMR. They're basically then, because of their economic precarity, driven to do these things. So economic precarity often also prevents farmers in these cases from adapting their farm biosecurity practice further because they lack the financial resources to implement them. And as the paper notes, even with relatively well-managed farms, AMR risk and decision-making related to antibiotics was shaped by the immediacy of business collapse and loss of food supply. So should a farm pause its sales due to disease outbreaks, the absence of financial safety nets could result in substantial, even catastrophic loss of earnings, not only for the farm, but for any business that relied on the farm's produce for its survival. Thus, even though farmers and veterinarians are aware of the harm AMR poses, many are clearly stuck in a cycle of economic precarity that drives continued dependence on antibiotics to keep their farms and their livelihoods running. So to repeat from the last four examples, whether it be chicken farming, access to clean water, research and surveillance of AMR, human use of antibiotics, or many other things related to AMR, these can all be understood within complex, interconnected, and contingent relations. So there's many overlapping factors that are driving the spread of AMR, basically. Okay, so to move on a bit, I want to highlight that there are evolving ways of studying AMR in the social sciences and humanities. One is the growing focus on antibiotic use outside the global north, so outside of like North America and Europe, where there's been huge amounts of research done, but very little of the global south. So the global north has been a major focus for decades, but within the past decade, and say since the 2010s, research has begun to realize the impact AMR will have on the global south, and that research must focus on these areas in more detail. As Overton and colleagues describe it, defining AMR as a threat to northern biosecurity risks ignoring important southern perspectives and also risks prioritizing regional over planetary solutions. Secondly, there's more efforts to engage with AMR beyond one type fits all behavioral or structural or technical solutions. For example, earlier studies might suggest that the solution to AMR is public education and awareness of the dangers of antimicrobial use. And this theory or way of thinking is known as rational use. Another one type fits all example is earlier studies might have focused on the technical solutions of precision medicine, for example, such as targeted diagnostics and treatments. And many of these viewpoints have been critiqued since then for addressing the issue of AMR too narrowly. Nowadays, studies have shifted away from these viewpoints towards surveillance and stewardship. So while these interventions of surveillance and stewardship are much more comprehensive in scope, as we saw in some earlier slides, things like surveillance might require levels of infrastructure and standardization that certain areas, especially in the global south, cannot provide. So still there's issues with the current interest in AMR in the social sciences, like surveillance. But as this presentation has hopefully made clear, AMR is a complex issue. So solutions must also be thought of as multifaceted and interconnected. In many respects, solutions must be thought of increasingly from global south perspectives and not from top-down global north interventions. Thirdly, there is more engagement with not just the human and animal, but also environmental aspects of AMR. This includes thinking of the environment within eco-social and One Health perspectives. That is, seeing its interrelation with human and animal aspects as the growing acknowledgement in social science of the significance of non-humans and their effect on social systems. For an example of non-humans in social systems, we can think about the significance of environmental pollution on human health. And going a bit more into evolving ways of studying AMR, I wanted to point out some examples from the theoretical fields within the social sciences. So, for example, political economy. Political economy studies the role of the state in economics. And in the case of AMR, this could be the role of the state in economics of public health. And political economy is quite good at pointing out asymmetries in power and in access. So Beale in 2007, for example, has talked about the public health has been reduced to just the provision of pharmaceuticals. In other words, it has been pharmaceuticalized and just focused on giving medicine and treating people in that way. In the field of science and technology studies, as another example, science and technology studies follows the practice of science and technology. For example, how science is shaped and constructed to produce particular epistemologies or ways of knowing. And one can look at Hannah Landecker's work from 2015 on the history of antibiotics. Similar to science and technology studies or related to it, there's multi-species ethnography, and this focuses on the entanglement of humans and non-humans, how we live with and against other species like mammals, insects, fungi, and microbes, our conceptual and material relations their conceptual and material relations with humans, and the ways that economic, political, and cultural processes shape these relations. Multi-species ethnography is quite focused on the decentering of the human. So it's very interesting that it's part of the social sciences because it's quite antisocial or quite unfocused on the human. And one can look to, for example, Heather Paxson's work in 2012 on cheese production and pasteurization, and that related it to antimicrobials. If one wants to learn more about multi-species ethnography, you can read Kirksey and Helmreich's work on multi-species ethnography, which outlines it as a theoretical practice and as a methodology. There are other theoretical fields as well. For example, infrastructure. You can look into Boker and Starr's work for their formulation of infrastructure. There's also public policy, which is a huge, huge field related to AMR. And some, I don't put any references here because it's just such a huge field, but there are some topics such as the governmentality, if you think about Foucault, of AMR. There's also global norms around AMR. There's the enactment of policies around AMR, et cetera, et cetera. One can also study discourse analysis. For example, Brown and Crawford and Iona Walker have written on war metaphors related to AMR, how it's like something we should fight and it's an enemy out there. And Brown has also written on biosecurity in relation to AMR. So those are some examples within social sciences and humanities of ways to kind of access AMR if you're interested. So now to turn to the interdisciplinary study of AMR. The social study of AMR is broad, a highly useful way of studying AMR. However, especially as regards AMR, there is a need for integrated interdisciplinary knowledges. While I outlined in the previous slide theoretical approaches based in the social sciences, like multi-species ethnography and science and technology studies, these are not exclusive to the social sciences, and they are themselves in many ways interdisciplinary. For example, like social science and technology studies takes a lot from the biological sciences. So it in of itself is quite interdisciplinary. And the need for interdisciplinary knowledge applies to research on AMR, as well as general public understandings of AMR. So it's not just here within academia that there should be interdisciplinary knowledge of AMR, but more broadly as well. Microbiology and sociology can't exist in disciplinary silos in the context of AMR. Thus, social drivers need to take into account biological drivers of AMR to understand the situation in full. This includes the integration of knowledges from social, biological, this includes animal, environmental, microbial, and medical disciplines. This viewpoint is agreed by many, including Smith and the WHO, who argue that antimicrobial resistance is a global threat to public health that has been increasingly recognized as a biosocial phenomenon requiring input from the social sciences alongside biological and clinical sciences. This outlook is in line with the One Health framework, and perhaps last week you heard Nina's talk on One Health. So just very, very briefly, the One Health framework has been in use for at least a decade now within AMR to describe AMR as one of interconnection between human, animal, and the environment. And a project I want to highlight that is about the integration of disciplines and will be conducted in Jogja is BMAR, which is a very long acronym, which stands for Finnish Multidisciplinary Center of Excellence in Antimicrobial Resistance Research. Marco touched upon it in his presentation. Currently, we have field sites in Beni and soon in Indonesia. And the aims of our project include studying the emergence, spread, and drivers of AMR. And to do this, we're planning to do a deep study of each field site, which means like we're doing a deep sectional study. So we're going from how people, for example, wash their hands to what food they eat or what animals they're in contact with, up to national and global AMR policy. And this deep sectional study also includes connections. So, for example, family's food, is it from a market? So then the idea then, if so, is then to conduct samples and or interviews there at the various connections to members in different households. And our project is made up of multiple teams: sociology, environmental microbiology, and medical microbiology teams will be conducting fieldwork together. And these teams will collaborate with local researchers, meaning that each Finnish-based team will work with a similar local team at each field site, so a Jogja-based team that we will work with. The environmental microbiology team, for example, is already planning to do work with Prof. Siti Subandia, and our sociology team is in the process of finding social science collaborators, and that is why I'm here in Jogja right now. And our methodology includes conducting surveys, interviews, and participant observation. So essentially a short ethnography. The microbiology teams will take human, animal, and environmental samples. And we are basing our data collection around what we call index households. So they're families that we study deeply, what they do, what they eat, where they go, who and what they interact with. And this gives us an idea of the spread of AMR through different people. And we are planning the majority of our data to be integrated into one platform. So, last slide. So, for some conclusions, I want to say that the social study of AMR includes multiple scales to understand AMR from the global down to the local. There are multiple fields and disciplines within the social sciences, like sociology and economics, and there are various interdisciplinary connections between them to describe and talk about AMR. There are also other disciplines outside of social sciences and humanities, like the biological sciences. So the social study of AMR should not exclude these other disciplines, and interdisciplinarity is an important future trajectory for the study of AMR. And finally, AMR can be understood within complex, interconnected, contingent relations. So, terima kasih. Thank you.
Thank you, Aditya. Very complex and detailed presentation. We have enough time for discussion. Please, maybe participant from this room or maybe from the Zoom, because we have still maybe now 31 participants from the Zoom. Any comment?
Yes, I'm happy to take your questions or comments, or if nothing was, or if something was not clear. Happy to discuss further.
Yeah, okay. Please tell your names and affiliation also. Maybe we can use the other microphone. Oh yes, please. Okay. Yeah. The back side, please. Yeah. Jadi itu kan sudah di energy. Okay. Yeah.
Okay, hello, my name is Misna. I'm from Brand Protection DGM. First of all, I want to say sorry if my English is bad, but I want to ask you two questions. One is, what can we, can we, can we, can we do as the general public to stop the air spread or to stop the EMF? The second question is, how can we control the biological drivers for EMF?
Can you repeat the second question? How can
we control the biological driver of EMF?
Okay.
I'm sorry, control the
biological driver. Biological driver.
Yeah.
Okay. IMR. Okay.
I feel like this question is for both me and
Yeah.
Marco.
Oh yeah. Okay, there are two questions, Alicia, and also maybe the last one related to Professor Marcus. Please. Yeah.
Well, okay, I can speak to the first question at least. What can we do as the general public to prevent AMR spread? That's a really good question. Again, I feel like it's quite multiple and interconnected. Like there are daily practices one can do, like wash your hands, try and have good health hygiene for you personally. Also personally, try not to use antibiotics too much, or only use it in if you're very, very sick, or maybe is given by your doctor or hospital. Also good to be informed. For example, I've understood that many people take antibiotics for not necessary reasons, like maybe you have a viral cold, and in that case, antibiotics will not help you at all because it's a virus, not a bacteria. So good to know these things, like general biology things. And of course, education is very key there. It's just in my presentation, I was saying that only education and only informing the public does not do enough to help the AMR issue, because there oftentimes are many other things at play that prevent people from not using antibiotics. For example, with the chicken example, a lot of farmers are quite close to becoming very poor or losing their business, so they're pushed economically to depend on antibiotics. So these kinds of things have to be researched more, understood more. So as a person of the general public, like, inform yourself and those around you. Potentially also push your local government as well. In what sort of ways, I'm not exactly sure yet, but it is something that should be bottom up, but also top down. So yes, I will keep my answer like that. Yes. Would you like to do that?
The second question, Professor Marco, maybe. Yeah.
Yes, of course, most of the biological drivers are controlled by non-biological actions. So actions in the society, and for example, how to increase the sanitation. It's more like it has so many advantages, so that there are so many reasons to make the sanitation better. But that's, of course, we know that in biological and technological viewpoints, so it's other questions. There are, however, some kind of biological drivers that have biological or medical solutions, such as improving the diagnostics, humans and animal disease diagnostics, so that the antibiotics will only be used when they are effective, and the correct antibiotic will be used when needed. And that's kind of inside the medical practice. Same goes with how hospitals are organized and how well is hospital hygiene taken care of. Of course, that's also a little bit a social question, but it's still inside the medical profession. And usually there is, in each hospital, there is room for improving hygienic practices. Also, farm security, farm biosecurity is something that is more like, I see it more like a biological thing, that it should be improved. But still, most of the biological drivers, they are controlled by actions in the society.
Human behind the biological aspect. Man behind the gun. Okay, thank you, Alicia and Professor Marco. We still have time, please. Another question? Yeah, please. Yeah, please tell your names and also affiliation. This international student.
Hello everyone. Hello everyone. Daisy from Vietnam. I saw that in Vietnam we have like 62% of use antibiotics. So actually it's on my mind because it's easy to buy. I just have like something to share, not like question. I easy to buy antibiotic in Vietnam. Yeah. So since I come here, my eyes had some problem. So I cannot buy like some drop eyes have antibiotic. I feel that it's inconvenient, but I know that it's not good for my health. But it's on my mind, so I don't know how can I through it. Just like something for share from Vietnam. Yeah.
Okay.
But in here, but in Indonesia, it's hard to buy antibiotics. And that's why I feel it's so different in Vietnam and Indonesia.
Okay, really interesting comment.
Thank you. Still only one question? Enough? Okay. Yeah, please, Prof. Marco or maybe Alicia. Oh.
Yeah, maybe I can kind of comment on that. For example, in Finland, public opinion has changed a lot in recent years. At least partly so that if previously people wanted to have antibiotics when they went to doctor, and they wanted to have antibiotics for their child when they went to doctor. Now at least some of the people, they question the doctor. So it is really necessary to take antibiotics because we also know that it's bad for all our own food microbes. So it's, if you don't need antibiotics, then they will not make your health any better. They may make your health worse.
Alicia, you want to respond? No, enough?
No comment.
Okay. Please, from the right side. Right side. Any other comment? Okay, please. Yeah. We have one question. Yeah, please. Yeah.
Hello, my name is Akisur Zingupran from Brand Production. I want ask about if someone is already infected, like tuberculosis or pneumonia, where the patient needs antibiotic every day. How can antimicrobial resistance be addressed in patients requiring long-term therapy? Thank you.
Okay, thank you. Please, Professor Marco.
So can you repeat the actual question? Can you repeat the actual question?
Yeah.
How can AMR be addressed in patients requiring long-term therapy?
Long-term therapy.
Yes. So the short answer, as the viewpoint of patient is that patient doesn't have to think about that at all, because tuberculosis especially requires lots of medical attention, and there is always doctor who is treating the patient. And treatment of tuberculosis and resistance in tuberculosis, it's quite unique case. So with tuberculosis, it's a very long treatment with antibiotics, and it's very important to complete that one. The development of resistance takes in fact place in the patient itself, and not so much the horizontal gene transfer, but by mutation. So it's the short answer is to follow the doctor's advice.
Okay. Okay, thank you.
Sorry, one thing more. The idea why we are interested in AMR is that we need antibiotics, and we want them to be effective when they are needed, and they should be used when they are really needed. So just that we should try to reduce the use when they are not really needed.
Oh, okay. Only for needed. Yeah. Any other comments or questions, please? Anyone from Zoom meeting? Those from Zoom, no comment. Actually, we have 30 participants from the Zoom. Okay, yeah. In the corner, please. Yeah.
Hello, good morning, I think, everyone, and welcome, Prof. Alicia and everyone. My name is Putu. I am a doctoral student of University Bandia, and I am a veterinarian here, and I would like to a bit comment with what you just said. With the microphone, what just you said, and what you just asked to Prof. Marco, and what Prof. Marco just said. I'm agree with Prof. Marco why we have to concern with the antimicrobial resistance because of the unwise use of the antibiotic. If the patients we talk about human or animal is need for antibiotic because they are diagnosed by the bacterial infections, we cannot do anything. We have no any choice other than to give the antibiotics. But what we concern is the unwise use of antibiotics, or the use of the antibiotics without any control and without any diagnosis. Because one of the problems in the animal health, I can say only the animal health, I cannot say the human health, because sometimes in the field, the veterinarian has a lack of technology to diagnose the disease, especially in the ruminants like cattle, goats in the field. It is really hard for the veterinary to get a correct diagnosis from the animal. So, and the problems from our place is we have a very difficult geographical area that the veterinarian cannot come there for every day to see the cattle, and they cannot take the blood and send to the laboratory because, of course, it takes more money. So veterinary usually they use antibiotic for prevention, even though they know that they don't know yet the diagnosis, and they don't have any choice. If they leave the cattle, and maybe because of the lack knowledge of the farmer, and maybe they are not patient enough, they will go to another, like the animal health staff. It's not a veterinarian. They will ask drug and they will give the antibiotics. Maybe it's more no any control from the veterinarian. So the veterinarian doesn't have any choice to give the antibiotics. One of the problems, and I think it's one of the solution in our part, is not only controlling the antimicrobial resistance, but also develop some diagnostic tools to make the veterinarian make easy to diagnose the disease, so they know when they can use the antibiotic and not using the antibiotics. And another thing is, what about if there is no antibiotic used in a certain area, but you have seen that how the resistant genes and the antibiotic can spread throughout the environment, and in the environment there is a lot of reaction, which is in the agricultural antibiotic resistant bacteria can make a reaction with pesticide residue and can increase and express more the antimicrobial expressions, and that makes our environment have a more contamination with antimicrobials. So what we want to concern is how to make the antibiotic as small as less as we can. We know that resistance always occur in every part, but if we use the antibiotic wisely, the branch of the resistance we can prevent, and it can come a little bit more slower, not as fast as now. Like I think Alicia showed you that the resistant antimicrobial resistance can cause death more in 2050, and if we not do the control, maybe 2050 can come closer, especially in Indonesia. We have 3 outbreaks in animal, and of course we use antibiotics more. I can say that maybe 2050 can come closer, or the number of the people dead can be increased. So we have to hold the hand together and work together.
Okay, thank you. Additional information, yeah, very interesting Indonesian case of the antimicrobial resistance.
Thank you, Putu. Very good words, and I would also argue that in general, almost every country there is lack of veterinarians. So I think that we should, at least in Finland, we should say, educate more veterinarians, probably based on Putu's comment also in Indonesia. There should be, because we want to have more animal products as a society, so it means more animals. We should also have more veterinarians. Yeah.
I also wanted to say thanks, Cookie, for your comments. Really good, good overview. I also wanted to comment that you mentioned diagnostic tools could be very useful, and I agree. And I think it's not so focused on at all. I recall one of the papers by my colleagues, they mentioned in Benin and Burkina Faso that a lot of the chicken farmers themselves, because they don't have much money, they're diagnosing the chicken diseases themselves. So probably having some diagnostic tools to help them diagnose properly would be very helpful, and also help more, I think, communication or some better link between the farmers and the veterinarians. In the paper, it seemed like the farmers and veterinarians, they're, because of costs and because the veterinarians can't travel so far and they know they might risk further infection if they visit the hospital, they don't visit the farmers so often. So there's this distance and this miscommunication that happens between those two, which is very interesting. Yeah. So thanks for your points.
Okay, thank you. Dr. Please.
Thank you very much. Alicia, that's very nice. I think I would like to give some comment as well for our student from Vietnam. Yes, in Vietnam, maybe 60% use of antibiotic. Maybe the data is for human diseases. While in here, for human diseases, the use of antibiotic may be much less. Yeah, because the rule or also your economic, when antibiotic is quite expensive, so we don't use humans. However, some antibiotics which are already maybe old or expired or whatever, they may go to agricultural.
Oh.
So actually, the use of antibiotic in agricultural practices maybe even much higher than for human disease. So that it is something that we have to be
There's
aware.
probability.
And something else is that to change the attitude of the public, it is quite difficult, right? And in this case, like in our case for plant health, farmer already told that only use pesticide with a certain dosage or concentration, something like that. But in their mind, they will not have they will not harvest their agricultural product if they don't do any pesticide spray, something like that. That's only that's very strong in their mind. So that's why they even spray their plants twice a week or even 3 times a week, something like that. So actually, not only pesticide, of course, antibiotic itself. We last time we found that antibiotic already banned from the government, not to be used in agriculture. But we still can find in the store, and farmers just buy bottles to spray their plant. Right? And of course, I think also in the chicken, poultry,
fish,
fish
industry,
and also in the fish fishery, in the fish pool, they just use it. So see, that's things that problem. It is quite difficult for us. And how to drive this as kind of community, to know more about the AMR and how to stop the spread. It is sociologically, yes, maybe it is quite difficult, and also because mostly I think in Indonesia, social scientists, they may only, mostly studying the sociology, but not the
connected to
not to the biology. While in developed countries, they may a sociologist or manager, something like that, they know already in detail what is the substantial for them to inform the public. But in Indonesia, even in our faculty, maybe the student study more on the sociology itself, but not in the agriculture or plant protection or something else. They ignore maybe. But actually, to inform the farmer, to inform the public, we should know in detail what is the problem related to biology. Thank you.
I agree. Yeah. Just to comment back that I feel like social scientists are constantly jumping between scales. Like you were saying, these pesticides, are banned by the government. Okay, but then still at the local level, you see its use, and there's a very strong culture of its use. So that's very, very interesting. Yeah. Just to comment that there's a lot of scale jumping as a social scientist.
Should we have kind of how we have human doctors, we have veterinarians and human doctors. Could we also have plant doctors? So we can think about that. And also I think we have the similar problem with kind of in general getting social scientists to interest in biological problems. Of course, we have collaborators, but they are, I think they are more like exception than the rule, even at least in Finland. So it may not be that good situation, in Europe and so on. So I think they have a similar question.
Thank you.
Okay, thank you. Still, there any other question? Yeah, I just want to comment, Alicia. Yeah, in Indonesia, we can differentiate into two type of the farm business. The type is very intensive, commercial, and high risk. Intensive, commercial, high risk, and then second type, not so commercial, and then low risk, and usually not so intensive. And then the behavior of people usually depend on this type of activity. In the first type, usually people want to make secure first. In order to make secure first, usually they use so many inputs, including the antibiotic and so on. So this is for security. So maybe our homework in the future how to mix the intensive commercial and high risk, but with the more sustainable activity, more responsible. But this is our homework actually also. So maybe we could study about comparing these two situations, and this is because this situation leads to the behavior of the people. They will save first, secure first, and then maybe the impact on environment, impact on health, maybe the second choice. Yeah, like in the livestock industry, also chicken industry, fisheries also, because it is high risk, and then they will try anything to make secure first. Yeah, including using the antimicrobial. Yeah, so. Just, yeah.
Yeah, because on a general level, it makes a lot of sense to force it to secure yourself to prevent problems down the road. You would use a lot of antibiotics. I don't know. I can see that as a rationalization for why farmers would want to do that. But then it's interesting because at the same time, it's totally opposite to what's called like biosecurity measures, where you're trying to use as little antibiotics as possible, and you try and have a different kind of, or like this focus on hygiene and sanitation in the farm as a way to prevent disease. Yeah, it's a really interesting way of how people think of disease and risk. Yeah, and it's all tied into business, livelihoods.
Okay, so improving the capability, knowledge, awareness in the region may be very important at any level especially in Indonesia. Not only putting the priority on economics, but for the other issues, environment, health and so on. Yeah, time is up. Usually 2 hours. So the minute after 11. So if still there's question, maybe I will give one chance. Still another question? Maybe one question is still to be right? Enough? Okay. Yeah, we have learned very interesting topics this morning. Yeah, with Professor Marco and Alicia, we know about the EMR, also the very complex aspect, not only technical aspect, but also including environmental aspect, also social aspect, very important. So in the future, we hope also our faculty, our students also will have priority attention also responding this issue, because so far still very limited, maybe on our college from microbiology, from plant protection, but also social economics still very few. Hopefully in this lecture will give inspiration for do research in this issue, especially for social science in our faculty. So shall we give a big applause for the Professor Marco? Yeah, thank you very much. We learned a lot of issues in this morning, so it's very beneficial, very important for us. Thank you very much for this lecture, and thank you very much also for the students for your attention, your participation in the class. Thank you very much. See you next time on the next guest lecture. Thank you. We can have a picture together, Professor Marco, over there with the students. So we have a picture. And if it is possible to share your material to the student?
Yeah, yeah.
Okay, yeah, I will share the material to all of you if you need.
Yeah.
Please contact us. Yeah.
I can send you a PDF.
Oh yeah, okay, yeah. Video is better.
Yeah.
Smaller size.
Yeah.
Yeah, PPT is very big. Yeah. Video is better. Yeah.
Okay.
Okay.
Thank you.
Yeah. Yeah.
Oh, thank you. Yeah.